Welcome to my YouTube channel Cat, and today we will see in the magnetism what is the work done by a charged particle moving in a magnetic field B. Okay, so in the magnetism section we will see what is the work done. Okay, so work done by a charged particle. Okay, so suppose that the charge of the particle is Q, which is moving in a magnetic field of B. Okay, so what is the work done here? Okay, so suppose that this is B and this is B. Okay, so what is the trajectory? Trajectory will be like this. Okay, if R is greater than L. Okay, so what is the work done by this charged particle, or what is the change in the energy of this particle? Work done is equals to change in kinetic energy here. Okay, so if the work here the work done is equals to change in kinetic energy, because the potential energy is not changing, so kinetic energy will change. Okay, we don't see the change in height. Okay, so the potential energy is unchanged, only the kinetic energy changes. So work done is equals to change in kinetic energy. Here the velocity is v, so we will see what is the work done. Okay, so we know that what is the work. Okay, work is force into dot product of displacement. Okay, and here what is force? F is equal to q v cross b. Okay, and what is this d? D is nothing else but velocity vector. So displacement will be in the direction of this velocity vector only. Where the velocity vector will be here, displacement will be same as the velocity vector. We can always write this d vector or the displacement vector as the velocity vector. Displacement vector is equal to velocity vector. Okay, so q v cross v dot v. Okay, so we know that v cross b is nothing else but which is perpendicular to direction of v and b. What is v? V cross b. V cross b is that the resultant is perpendicular to v and b. So the resultant of v cross b is both perpendicular to v and b. Okay, so we know that the resultant is perpendicular to both v and b, so it is also perpendicular to v. Okay, so the dot product will be 0. Okay, so the q v cross b, the resultant will be resultant vector will be perpendicular to the this displacement vector or the velocity vector. So the resultant of q v cross b is perpendicular to the velocity vector, so the dot product of force vector and the displacement vector will be equal to 0. Okay, so the work done will be equal to 0. Okay, so the change in the kinetic energy will be equal to 0 in this case. Okay, okay, so the change in the kinetic energy is equal to 0. Okay, so the initial velocity v is equal to the final velocity v. Okay, so both the initial and the final velocities will be equal and will be equal to v, and the change in the kinetic energy will be 0. So the initially the particle is going with v, so the finally it will come with the velocity of v only. Okay, if the magnetic field is b, if the magnetic field is 2b, if the magnetic field here is changing b, 2b, 3b, 4b, then also the change in the velocity will be equal to velocity will by magnetic field on charged particle is equal to 0. Since the force vector is q v cross b and the displacement vector is nothing else but in the direction of velocity, so the velocity vector. So q v cross b dot b, and v cross b is perpendicular to v and b, so it is perpendicular to b also. So if perpendicular to b dot b, so it will be equal to 0. So the perpendicular dot product of two perpendicular vectors are 0. Okay, because cos of 90 is 0. Okay, so the dot product will be 0 or the product will be 0. So the change in kinetic energy will be equal to 0. So initial velocity will be equal to the final velocity if magnetic field is changing or the magnetic field is constant. It don't matter, only the radius will be changing by r is equal to m by qb. So qb b is equal to 2b. So the radius will be r by 2. Here the radius will be r by 3. So the radius will be changing here, but the kinetic energy or the velocity will be constant. So mv by qb, and mass is constant, velocity will also be constant. R is equal to mv by qb. Okay, like this you can see what is the velocity vector at the final stage. Okay, thank you.